I realized that I have an issue, is that my tube that should go into the bottle sometimes collides with the bottle. And I figured out why it is. Here in the machine itself, you see we have some play. And you see we have some play that is about half the width of the hole. So that is pretty much, I mean, it's, and then of course we're also not always gonna be sure that the bottle is at exactly the same space. So we want that tube to come down at the precise place. Now, why do we have that issue? This is one of my sliders I have made, and if you look at this, here you just have a straight edge. It's like a T-knot system. It's just gliding in there, and when it's gliding, you need some play, right? You cannot glide in a press fit, at least not with 3D printed stuff. If you do it in really ground steel in a lathe, you do that stuff, but not on 3D printed, and that stuff becomes really, really expensive. So I modified my whole thing. Now it looks like this, and these here are ball bearings. And of course also I adjusted the rails, and so now I can roll along rails, and so I can give it a little bit of pressure, and then I have no more play. And the second thing I have is, since I did everything with the 16mm hose, down here you see the difference. That's the 16mm hose I used in the peristaltic pump, because in the peristaltic pump I like having quite some wall thickness, because that gives you some flexibility and ensures that you have a nice closed valve. And so that's why I went for the 16mm, the original one I had. But I also have 12mm, and both are 8 inside. So inner diameter is the same, it's just thinner outside. But of course, this is much more flexible, because up here, if you look up here, where is it? Here is it. Here the hose comes in and goes here around the corner, so that I can unroll it up and down. But of course, the more that hose is stiff, the more it will push sideways into my slider, my lift going up and down. And so I will also change the hose diameter, so that new slider I made here, this cut out is already for the 12mm outer diameter, with of course the opposite part going like this. So I mean, if you design it well in CAD, changing it afterwards is just a few clicks of changing a few numbers, boom, send it to the printer overnight, and now it's putting everything back in and check if I get the rigidity I want. So it took 2 more iterations to get this to work, because first of all my rail was too narrow for the wheel to go in, which I have now corrected, and so now it has exactly the width, and it rolls nicely in that U slot with the width of the bearings. That was the first iteration, and after that I realized that on the sideways dimension it was too wide, it had some play, and I really want to have it snug with no play, because that will also block rotation, because I don't want rotation, because I want that tube to be straight. Now, how do you figure out how much play you have in a very narrow gap? That's what feeler gauges are for. So these stainless steel steel strips I got as springs, you remember maybe. And the gauge I had is 5mm wide. My bearing is 4mm wide, therefore my slot in the rail is also 4mm wide. So I had to cut it in half somehow with my scissors, but that worked. And so I pushed one in, I still had play, I pushed the second one in, and I pushed it into the rail, and then I rolled over it with the bearing. And then I saw, okay, with two of them, it fits, no more play, and it has a slight compression, so I can't easily pull the gauge out again. So that's about the value I want. And so I spread my two bearings by 0.2 millimeters. That is the new part with no bearings yet. So I need to put the bearings on, and let's test if now it fits. It worked. So I have that vertical lift precisely guided. Now I just need to put everything in, and then I can test if I finally can hit the opening of that bottle repeatedly and not miss it like last time. So with this contraption I could test my big load cell. So just so you get an idea, old load cell, new load cell. Well, so the part here inside, the rest around it was just so I could test it. And it is tested, 0 drift over 24 hours. I'm very happy. So it will give me a stable reading. It goes perfectly back to 0. So that is very good. My suggestion, if you're looking for load cells on AliExpress or wherever you're looking, check if they mention the drift. If they give you numbers for drift, because it's never going to be absolutely 0. But here it is 0.002% of full scale. So, I mean, if you have to recalibrate your scale every year, I mean, you can live with that. It's just not, you don't want to do it every day. Drift is something that happens, but if the manufacturer addresses it, it means he has measured it and he has an eye on it, which definitely makes sense. So that means I also have printed the new scale platform with the new load cell in it. That needs to go in. And the whole machine, as you see over here, is laying on the side. And now I can look inside what happens. Oh yeah, the power switch also came. I also have to integrate that one because, I mean, yeah, it's going to be a device I want to sell, so I need at least a power switch, just unplugging it. That is the bottom plate. Looks nasty, doesn't it? And it's sticky and it's smelly because it got a lot of beer. So that needs a clean. I mean, this one is easy. I could just take it into the sink and wash it off. All this stuff is going to be harder to clean. We'll probably have to take the sponge. But first, I think I have to change that water too. So, let's go to the sink first. One day I will have a lab with a sink. But now, just have to go over there to our, how you call that in English? In German it's eine Waschküche. It's a laundry room. Probably. No, you can call it laundry room, I guess. Beer has sugar, so let's turn on the hot water to help dissolve that. Get rid of that too. I forgot my sponge. Okay. These oxidation marks that happened, I don't get them off. Note to myself, maybe use anodized aluminium next time to not have these oxidation issues. Now, for sure, I need to clean that top layer here. Nasty part, especially where I'm gonna put back the new plates here, because that's where I won't be able to clean later. I mean, the goal is just to get it not sticky anymore. That's the main goal. Okay, cleaning is definitely not my specialty, but nevertheless, the most surfaces, I got them non-sticky now. I can continue assembling. What I need to assemble next is that little ADC I have up here, which I made a little holder because I need to move it to a different spot. But since I realized through my tests it doesn't like water at all, it doesn't die actually. If it gets beer, it still works, but the values start to drift, which is no wonder. You have millivolts and you have a liquid that somehow is conductive, that will of course then mess up your measurements. And for this I have actually got this stuff. Liquid isolation stuff. It is some kind of rubber. It's made for electrical isolation. So the idea is I make my connections to the board and then I paint or pour or whatever it. Oh, it has a brush in the can. Look, it's written on the cover. Brush in can. So do I need to shake it? I'm not sure. How does it look? Hard to open for sure. But it's a tool for everything. Okay. So, is it... What? But how the F am I supposed to use this? It's already solid. I think I got ripped off. That thing is probably expired. Does it even have an expiry date? I think they sold me expired shit. But yeah, it still looks somehow sticky. I mean, still can give it a try. I mean, worst case, it doesn't help, but it's not gonna harm. Did I take a picture of the... Because, look, again, I might have done exactly the same mistake. This is my cable for the data connection up to the board. I cut it off the board. And if you cut just the cable, how are you gonna figure out how it was connected back then, before you cut it? One thing I do sometimes when I think about it is to snap a little picture before taking the stuff apart, which usually makes sense. Doesn't mean I thought about this today. Yes, I have one. I have one picture that shows me how the pinout should be. Soldering iron. Wire stripper. So, and now I wanted to put... How did I want to put this? And that's where I wanted to put it. So, and then I'll have this one here. Yeah. Okay, it all makes sense. It all works. The only issue I have is the space issue. So I have no space to work here, but now I have space. Very, very useful tool. Inverted tweezer. So one that, if you let it go, it's closing. And usually the tweezer is much heavier than the board you want to hold. So ground is out already again, but at least I have VCC. Good. That should work now. Now, the big question is, does it work or does it not? Okay, now up here I have my board lying around. Down here I have the cable coming down. I hope there's no shorts if I turn that on. No, seems to work. And my screen here starts going crazy. I think it's the power supply that died, or is dying. It turns on and off every few minutes. So, refresh. Read scale. And, okay, I need to simulate that. Oh, I have a scale. But I have, oh, yeah, but I have a crazy value. But, how bad is that? I don't know yet. And the screen died again. F*** you, screen. I have to move that stuff over to the other screen. Come on! There's no way I can reach it. Oh. Makes me think of something. Okay, I could just... Oh, is it? No, it's not disconnected. Okay, but I can just go down here. And now it's alive again, of course. But no, I don't take the risk. You go off. And Windows recognizes, oh, I have only one screen, moves all the windows to that one screen. Okay, now I'd like to go to a calibration mode and press once to zero the scale, put my calibration weight on top, press another time. Okay, looks good. Now I want to go and read scale mode again. Now it's waiting for a bottle at the entry which I can simulate like this. Oh, it is f***ing noisy. Why is it so effing noisy? What the? I don't like that. Definitely not like that. Why are you so unbelievably noisy, you little thing here? I mean, I'm happy I tested it before putting the glue on top, because my first thought was to, yeah, just put the glue and go to bed because it's already late. But it's just noise. It is just noise coming from there. Unless I... Probably the board is bad. Means needs to be replaced. Means, I mean, you have seen it. Another half an hour soldering shit. And I don't have time for this right now. Or I could try some debugging too. I could at least... Well, let's try that quickly. Too short. Quite a day. I want to go down here, and that's all I have. Do I move my oscilloscope? Because I wanted to check the excitation voltage, how rough this one is, or how quiet. But I mean, if it seems broken anyway, let's try some experiments. Let's short the both signal wires, which should then basically lead to a reading of 0. Now, I'm pretty sure it's the chip that's dead. The chip itself. We'll need to start over again. But step by step. step by step. So now I have replaced that ADC that wasn't working. No idea why, but it's not worth figuring out why if that thing costs 90 cents or something. And I have now coated the new ADC in silicone. I know it doesn't look really nice, but it should at least protect it from dripping water or from water that might come in here. So now I have this holder that comes in, I would say, in here exactly, and then I can assemble the whole thing. And after that I can test the whole machine assembled. But for now, let's put that back together. Take 3. And I hope this is the last try I might try. It's the 3rd take of this f***ing video. Because first time I didn't have my microphone enabled, once again. And the second time I didn't even start recording. And so suddenly the camera shut off because I was not recording. So, now this is recording. I try to calm down. Yeah, and this one was not recording either. So, screen recording is going. Okay, what did I want to say? Yeah, it works. It's all together. I have the pump over here. I have the filling system over here. I have even real power buttons that show me if it's on or off, and I can switch it on or off. I have one over here also too. Also, and this is the connection that tells the pump if it should rotate and in which direction it should rotate. And then on the GUI side, on the software side, I added the retract feature. That means I pull back the liquid in the tubes a little bit after filling to avoid that it drips down, so that I have the tube empty, at least the vertical part, and so it doesn't drip down. And a second feature to also enhance that is that I pause after filling, so I wait for the droplets to fall into the bottle before I move the bottle. So these are the added features I put into software, plus a whole management system for different recipes, because this system will be used for different products and different types of bottles. But I can't tell you what, I can't show you what, but that doesn't matter for now. I will just use clear plastic bottles for now for testing. It's much better anyway to show you what's going on. And so I have a whole JSON file with all the bottle types and all the recipes what to fill, because I want to have the weight and all these parameters for each product type separately, so I can optimize them separately. Okay, now here on the GUI everything is ready. It asks for a bottle at the entry, so let's put a bottle at the entry. Now you might remember that I had issues. Let it fill first. And you have seen the progress bar on the GUI moving, so that works pretty nicely. Yeah, I had issues getting the tube into the hole of the bottle because it's pretty narrow. And I already increased the precision of the whole movement by adding ball bearings instead of sliding bearings, so I have nearly no play in that assembly. But that was not enough, so I needed to have another hack. The thing is, I have two pushers, left or right, and if I can push one a little bit further than the other one, the bottle will move left or right. And I used that, and it's also one parameter, of course, I can fine-tune in software. And so let me show you, if with only one bottle, then you see it better. So if you put that one in, it moves forward, and at the end of the stroke, you see it. At the end of the movement, you see it move it slightly to the side, and at the end of the filling I move it back into the center, because I have to put it back into the center to catch it at the next stroke. These are all optimizations that came through testing, and the good thing is I could do that all in software. And yeah, so I think I'm ready. Except that a few minutes ago my scale went crazy and I started overfilling bottles, so that's not so cool. The thing is, the whole software seems somehow reliable. I just have to somehow catch all errors that might happen on the scale. Because if the scale does something strange, I must be sure I don't overfill bottles. That's the biggest issue I have. So maybe I have to think a little bit more about my code, but except for that, I'm pretty happy with the result, and I'll be testing at the customer site very soon. So that's enough for today. Turn that one off, and that one off.